Hey everyone, and welcome. Today we're going to break down multi-threading. Now, that sounds super technical, I know, but I promise by the end of this, you're going to totally get it. We're going to make it simple, visual, and we'll start with a question you've probably asked yourself a million times. You ever stop and wonder how you can be listening to music, browsing a dozen tabs on the web, and downloading a huge file all at the exact same time? You know, it kind of feels like magic, right? But it's not. It's a fundamental concept in computer science. And the key to understanding it, well, it's not inside a computer chip. It's actually somewhere you've probably been a bunch of times.
Yep, to figure this out, we're going to skip all the confusing diagrams and technical jargon for a bit. Instead, we're heading straight into a restaurant kitchen. And trust me on this one simple analogy is going to unlock the whole thing for you.
All right, so first up, let's picture this, a small, simple kitchen. And in that kitchen, there is just one single chef. This is our starting point. This is our before picture, a world that operates on just one track. In this kitchen, our lone chef is, well, he's very methodical. He takes an order, he cooks that entire dish from start to finish. He serves it, and only then, only after all that is done, can he even think about taking the next customer's order. Everything happens one after another. If 10 people are waiting, he has to do that whole process 10 separate times in a line. I mean, he gets the job done, but man, is it slow. And there you have it. That right there is what we call single threading. It's one path of execution, our one chef handling every single task sequentially. A lot of simple programs work this way, and for a long, long time, this was basically how all computers got things done. But what happens when our little restaurant gets really popular? That single chef model is just not going to cut it anymore. The line's out the door, people are getting hungry, so what do? It's time to scale up. Suddenly, the place is packed. The owner's looking at this and thinking, okay, this one chef system is a total bottleneck. And really, the solution is pretty obvious, right? You hire more help. So boom, 4 new chefs are brought into the kitchen. Okay, so now check this out. Look at how the work gets split up. We've got one chef on biryani, another on pizza, a third is handling all the pasta, and a fourth is just on desserts. The key thing here is they're not waiting on each other. They're all working at the exact same time. They're working in parallel. And just like that, the kitchen's output, it absolutely explodes. And that, my friends, is multi-threading. That's it. That's the big idea. It's having multiple workers or threads working at the same time inside the same process or kitchen to get way more work done way faster. Okay, but it's not all sunshine and rainbows. You can't just throw more chefs in a kitchen and expect everything to be perfect. They all have to share the same space, the same ingredients, the same tools, and that's where you're going to run into some pretty serious problems. Just picture it. Chef 1 and Chef 2 both need the salt for their dish, and they both reach for the only shaker of salt at the exact same moment. So, who gets it? What happens now? You've got a problem. You've got conflict. And in the world of computer science, this exact problem has a name. It's called a race condition. It's when multiple threads are all racing to use or change the same shared thing, like that salt or a piece of memory, and the final outcome is totally unpredictable depending on who wins the race. This can cause all sorts of bugs and corrupted data in a program. But wait, there's more. Race conditions aren't the only headache. Let's imagine another kitchen nightmare. Let's say one chef takes the key to the main walk-in fridge, locks it behind him, and then gets distracted and completely forgets to unlock it when he leaves. Now, no other chef can get their ingredients. The entire kitchen just stops. Total gridlock. That's a deadlock. So, okay, we've got chaos in the kitchen, fights over salt, chefs getting locked out of the fridge. How do you fix it? It's actually pretty simple. You bring a manager. So the manager's job is to be the air traffic controller for the kitchen. They decide which chef gets to use the main stove right now. They make sure everyone gets a turn with the good knives. They're the ones who prevent these conflicts from happening in the first place. Basically, they turn that potential chaos back into an orderly, productive kitchen. And you probably guessed it. This kitchen manager has a direct parallel inside your computer. It's called the OS Thread Scheduler. It's the part of your operating system that's constantly juggling all these different threads, telling them whose turn it is to work, and making sure they don't fight over shared resources like memory. All right, the kitchen analogy has served us well, but now it's time to bring it all back to the real world. How does this actually look when you're sitting down and writing code for a program? So here's the mental model you should have. The whole restaurant, that's your process. Think of it like your entire web browser or a video game running on your machine. And the chefs? Those are the threads, working inside that process, sharing all the same equipment and ingredients. Okay, let's look at some real code. Now, don't worry if you don't read JavaScript. Just focus on the big picture here. That new worker bit, that's literally like hiring a new chef for one specific, really hard job and telling them to go work in the corner and not bother anyone else until they're done. So what's happening here is pretty cool. We've got two things going on at once. The main thread, that's our original chef, is totally free to keep taking orders or talking to the user. Keeping the app from freezing. Meanwhile, that new worker thread, our specialist chef, is in the background just cranking away on that massive calculation. The main thread doesn't have to wait for it. It isn't blocked. That is the power of multi-threading. So if you need to nail this for a job interview or just want to sound really smart, here's the one-sentence summary you need. Multi-threading means running multiple threads in parallel inside the same process. They share memory, but they execute their tasks independently, which makes for much faster concurrent computation. And that really brings it all together. From a video game that's rendering amazing graphics while it's also loading the next level in the background, to your browser using different threads to load all the images on a web page at once. Now that you see the kitchen, start looking for it. Where else do you see these busy chefs at work in your digital life every day? Thanks for watching.